In a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 power of minus 3 meter square and the separation between the plates is 3 millimeter. Calculate the capacitance of the capacitor. Second question, if this capacitor is connected to 100 volt supply, then what would be the charge on each plate? Third question, how would the charge on the plate be affected if 3 millimeter thick mica sheet of dielectric constant K is equal to 6 is inserted between the plates while the voltage supply remains connected? So here what is given? As per the question, A is equal to 6 into 10 power of minus 3 meter square and D is equal to 3 millimeter. Convert into meter, which is equal to 3 into 10 power of minus 3 meter, and dielectric constant K is equal to 6. These are the parameters given. Voltage is equal to 100 volt. The capacitance value can be calculated using the formula C is equal to epsilon naught A divided by D. Substitute the values. Epsilon naught is 8.854 into 10 power of minus 12 into A is 6 into 10 power of minus 3 divided by 3 into 10 power of minus 3. If you substitute the values, what do you get? Solve it. So you get it as C value, which is equal to 17.7 into 10 power of minus 12 farad. So that's the answer for the first part. And for the second part, if the capacitor is connected to 100 volt, what would be the charge? So for the second question, okay, Q is equal to C into V. So what you get? 17.7 into 10 power of minus 12 into 100 volt. So you get the answer as, okay, 17.7 into 10 power of minus 10 coulomb. That is the charge. For the third question, how would the charge on the plate affected if a 3 millimeter thick mica sheet of K is equal to 6 is inserted between the plates while the voltage supply remains connected? Okay. So to calculate the new charge, so for third question, new charge Q dash is equal to, you can write it as dielectric constant into the charge Q, which we already calculated. So 6 times 17.7 into 10 power of minus 10. So what do you get here? 1.062 into 10 power of minus 8 coulomb. That is the answer.